Hi, I'm Kevin Mealy, and I'm going to teach you how to do U.S. Coast Guard question 1654, which is Amplitude of the Sun, to find the deviation of the standard magnetic compass. The question states, on 28 September 1981, in DR position, latitude 27 degrees, 16.7 minutes south, longitude 113 degrees, 27.2 minutes west, you observe an amplitude of the Sun. The Sun center is on a celestial horizon. I always underline celestial because there's two different ways. If one is visible and one is celestial, you have to add a correction. With celestial, you do not have to add a correction. And it bears 273 degrees per standard compass. The chronometer reads 1 hour, 17 minutes, and 26 seconds, and is 1 minute and 49 seconds slow. Variation in the area is 6 degrees west. What is the deviation of the standard magnetic compass? So first, what you want to do is write down your givens, your latitude and your longitude. And then also the shot, which is 273 degrees per standard compass. And once again, it's on a celestial horizon, so you do not need to apply a correction. If it was on the visible horizon, you would need to apply a correction out of table 28. Here you do not. So we know that the sun is setting, so we take a rough estimate of the time, 1800. So GMT, our zone time, is roughly around 1800 on the 28th of September. Now, if we look at our longitude, which is 113 degrees, 27.2 minutes west, we divide it by 15, and that gives us 7.56 roughly, which we round up to 8. So the zone description is west. So you always add west zone description, so plus 8. So that time, a rough estimate of the time is 0200 on the 29th of September. And note that's the 29th of September, it's the next day. So when you go on the Nautical Almanac, make sure you're looking at the right date. Now also the question gives us chronometer time and error. And the chronometer, they say, is slow. Whenever the chronometer is slow, you add the correction. So the chronometer, 1 hour, 17 minutes, and 26 seconds, and it's 1 minute and 49 seconds slow. So we're going to add that, and you're going to get 01, 19, 15, which is 01 hours, 19 minutes, and 15 seconds GMT. This is the number that you take and go into the Nautical Almanac with. Now that we have our time of GMT, which is 01 hours, 19 minutes, and 15 seconds, we go into the date, which is the 29th. Don't forget, we went ahead a day. So now that we know we're on the 29th of September at 01, 19, 15 GMT, we must find a declination. Now, in order to get the declination, you must look under the column of sun. And I go to the 29th of September, and I go to my time of GMT, which is 01, 19, 15. At 01, the declination is south 2 degrees, 18.2 minutes. Now that I go down the column to D, and I see that D is 1.0, I write that down. And the correction for D is add 1.0. So where did that come into play, you ask? Well, you go to the back of the book into your minutes and seconds, because you're not exactly at 01. You're at 01, 19, 15. So you got to correct the declination for 19 minutes and 15 seconds. So I go to the back of the book to my increments and corrections, and I go to 19 minutes. I go into the sun column, and remember, it's 1.0. So I look for V or D correction column, and I go to 1.0, which was my D, which I found on the 29th of September, and it says 0.3 for the correction. Now remember, D was added because declination was going up, so I add the 0.3 to 18.2, and I get 18.5 south. So the total declination is 02 degrees, 18.5 minutes south. Now, when you do an amplitude, you can use a calculator and figure out the exact bearing. You might need to add a little correction if the sun is setting, which is you add 180. So you take the cosine of the bearing, which equals the sine declination of the cosine latitude. We now know declination, and we now know the latitude. So we plug and chug. We plug sine of 2.30 divided by the cosine of 27.27. And how I got those decimals in the declination and latitude, as I took the minutes and I divided it by 60. And that equals 0.04 over 0.88, roughly. So you take the inverse cosine of 0.04 over 0.88, and that's going to give you a bearing of 87.4. Now you add 180 because it's setting, and you come out to 267.4. Now that's your true bearing. PSC was given, your per standard compass, of 273. Your variation of 6 degrees west was given. So plug and chug once again. Right here we have our true 267.4. Our problem stated that the variation was 6 degrees west. We add that. We get a magnetic of 273.4 degrees. And our per standard compass is 273. The difference between there is 0.4. So go ahead and write down 0.4. Now how do you know if it's west or east? TVMDC. Truly valiant Marines don't cry at weddings. You add west. So it's going to be east. Because by adding west, if you add 0.4 to 273.4, it would be 273.8, and that would be wrong. That wouldn't be your per standard compass. By using east, you subtract when you go in the right direction from T to C. So 273.4 minus 273 is 0.4 east, and that is your deviation. Thank you for watching. I'm Kevin Mealy. And once again, that was U.S. Coast Guard question 1654.